When adding and subtracting fractions, that includes comparing fractions as well. So if we're wanting to make a decision as to which fraction is larger or smaller, one thing that we need to know, very, very important, denominators must be common first. Okay, so that means then if the fractions have different denominators, we cannot add, subtract, or compare fractions unless the denominators are identical or made identical somehow. Also, when we're dealing with mixed numerals, okay, it might help to convert the mixed numerals into improper fractions first before any addition or subtraction. Let's have a look at some examples. First one, part A. Okay, evaluate each expression and simplify fully where needed. It's an expectation that when we're adding, subtracting, or wouldn't even say comparing, but adding, subtracting, multiplying, dividing fractions, that the end result is fully simplified, okay? Especially in situations where you're not allowed to use a calculator, all right? Not saying that you will necessarily lose marks because of that, but that's a possibility, okay? Especially it's an expectation in mathematics that when we express an answer, that it is expressed in simplified form, all right? So evaluate each expression, simplify fully where needed. 2 on 5 plus 1 on 5. First things first, check the denominators. Are they equal? Yes, they are. There's nothing we need to do apart from adding the numerators together. Okay, so that's just going to be 3 over 5. Always ask yourself the question, is this fully simplified? Yes, we can't simplify this any further. What about part B? 3 on 5 plus 3 on 10. Now, denominators clearly are not the same. They're not common. However, we could make them common by multiplying this fraction here, 3 on 10, by 5, and multiplying the first fraction here by 10. But that would create fairly large numbers. It's easier to see that we could, in fact, multiply the 5 by 2, and that'll give us 10. Okay, so that's another thing that we could do is just check the two denominators. If one denominator can divide the other, that simplifies things. Okay, so let's multiply the first fraction by 2 over 2. Okay, top and bottom by 2. And let's evaluate that. 3 times 2 is 6. 5 times 2 is 10. So that's the equivalent fraction. 6 over 10 is equivalent to 3 over 5. Okay, the second fraction, we don't have to do anything to it. All right. Now, denominators are identical, they're common. We can just add the numerators together. So that's going to be 9 over 10. Again, we can't simplify this any further, so we just leave the answer as is. All right. Part C. 9 on 10 minus 5 on 6. Okay. Again, we can find the common denominator. It doesn't have to be the lowest common denominator, but in this case, maybe we could multiply the second fraction by 10 on 10 and multiply the first fraction by 6 on 6. Okay. So basically, it's you take whatever the fraction is. Okay. If there's two fractions involved, the one fraction you multiply it by the denominator of the other. So 9 on 10 is the first fraction, multiply it by the denominator of the second fraction, and vice versa. Okay, second fraction by the denominator of the first fraction there. Right, 9 times 6 is 54 over 60. Okay, so that's the equivalent of 9 on 10. Minus 5 times 10, which is 50, over 60. Okay. 54 minus 50, denominators are now identical. We can just subtract the numerators. So 54 minus 50 is 4 on 60. Notice that the fraction that's resulted, 4 on 60, it's a whole number. Okay, or sorry, not to say whole numbers, they're both even numbers. So we can divide top and bottom by 2. Okay, if that makes it a bit easier for you. So that's going to be 2 on 30. Notice that what we get here again are two even numbers. Even numbers are divisible by 2. Okay, 2 divided by 2 is 1, 30 divided by 2 is 15. And so the answer is, or the fully simplified answer is 1 on 15. Okay, let's have a look at part D. Part D, you have a whole number minus a mixed numeral. Okay, so what we could do here is we can convert the first number, or the whole number here, into a fraction. Okay, so 3 is really the same as 3 over 1. And 1 1/4, let's convert that into an improper fraction. So 4 times 1, okay, so we multiply the denominator and the whole number. 4 times 1 is 4, 4 plus 1 is 5. Okay, so 1 1/4 is the same as 5 over 4. Now we need to convert the denominators into common denominators. Okay, we can take the first fraction and we can multiply that by 4. Okay, the entire fraction by 4, as in numerator and denominator multiplied by 4. 3 times 4 is 12. 1 times 4 is 4. Minus 5 over 4. Nothing we need to do to the second fraction there. Now, denominators are common. So 12 minus 5 is 7. Okay. All we need to ensure is that the denominator of both fractions are identical to each other. We don't have to do anything else. Just make sure they are identical first. 7 on 4, if we need to convert that into a mixed numeral, 4 into 7 goes once, remainder 3. And we write the remainder as a fraction, 3 over 4. All right. Last one. 5 1/3 minus 3 4/5. Okay. Might use a different color pen this time. Give the green pen a break. Okay, I think first things first, let's convert them into improper fractions. It does make life a little bit easier. All right. So 3 times 5 is 15. Okay, 15 plus 1 is 16. So that's going to be 16 on 3. Minus 5 times 3 is 15. 15 plus 4 is 19 on 5. Okay, denominators now need to be made common. Let's multiply the second fraction by the 3, by the denominator of the first fraction, and multiply the first fraction by the denominator of the second fraction. All right, moving on. 16 times 5 is 80 over 15. Okay, so that's the equivalent fraction of 5 1/3, in fact, as an improper fraction. Minus, now 19 times 3 is 57 over 5 times 3 is 15. Now we have the denominators are identical, they're common, we can now subtract the numerators directly. All right, so 80 minus 57 is 23 over 15. And we can convert that into a mixed numeral if we need to. Okay, and it's very important. If the question clearly states convert it into a mixed numeral, well, you're going to lose a mark if you don't do this. Okay, so 15 into 23. Okay, goes once, remainder 8. And write it as 1 and 8 on 15.